When you think about agriculture, you probably think about farming. You might even think about grocery stores. Or the many steps between the two. But you might not know about this key link between what farmers grow and what you find on the shelves. I am talking about the education, research, testing, and product development that goes on at places like here at the Northern Crops Institute. The Northern Crops Institute, or NCI, is on the campus of North Dakota State University in Fargo. They took me on a tour and I got to learn about what they do firsthand. David Boehm, technical manager for NCI, showed us around this incredible facility.
Our first stop was an auditorium. Here they teach classes about commodities trading, grain uses, innovations, and more. The classroom is well equipped for in-person and virtual learning. Attendees from all over the world take these classes, so it is even equipped with simultaneous translation services.
NCI also offers technical services, meaning that clients can hire them to do testing, consulting, research, and product development. Their range of expertise and capabilities include baked goods, extrusion, soy products, feed production, oilseed, pasta, and milling. Let's start with milling. One of the things that make this lab so special is that it is a full-scale, pilot-sized operation. Mr. David explained how roller mills work.
We able to do some other things near with soybeans and whatnot, but you'll see two rollers. It's a roller mill, and there's 18 different stands, and every one of them has a different corrugation on those rollers, and they're rolling inward together. And so you take a piece of grain, and it's just going to start breaking it apart. And the whole process of milling is taking a large grain and then getting it into a flour.
They can process a wide variety of grains and mill to a wide range of sizes, including flakes. These flakes are soybeans. This mill has a different size set of rollers. After the grain passes through one mill, it can be screened and flow through to another mill. The sequence of mills it passes through depends on the specifications they are milling for. There are multiple levels of machinery above the roller mills. Air conveys product to the top level, and gravity and vibration convey it through the machinery. Most of these machines are used to clean the grain or separate it by size. Some of the machines use simple screening processes. Some used advanced technology, like this camera system. The camera sorts by color. If it detects something that shouldn't be here, it blasts air at it and blows it out of the flow into a waste collector.
Whether it's simple or high-tech, all of it is very clever. This is a simplified process flow. The real process is more complex. A simpler milling process is stone milling. We got to see that, too.
At the top level. And then by turning there, you can set the gap of that level. So stones are moving in opposite directions. The top stone has furrows in it, or kind of grooves that channel at an angle outward. And so then as it's grinding, then that flour will push its way out to the outside, and then it's collected.
Okay, so level 3.
Flour from the stone mill can also be directed to the sifter attachment. In here, the particles get sorted into two sizes. Particles small enough to pass through the screen fall into a bin on this side. Bigger particles fall into a bin on this side. The operator can set the gap between the stones and can control the speed it turns. The stones are made of granite and provide a lower temperature process, protecting the natural oils in the grain.
Later on our trip, we saw this display at a riverside park and it knew exactly what it was. A milling stone. Beyond the milling lab are several other labs. In this lab, they test extrusion products. Wondering what an extrusion product is? Cheetos is my favorite example. But there are lots of other extruded products, including many popular snacks and breakfast cereals. I'll let Mr. David explain how it works.
You can dump it into the top, and then there's a couple different this is your first mixing chamber. There's 2 screws in there that are blending and mixing. And so when you're mixing that flour up, you're going to have moisture, water, if you're adding a little bit of oil, or whatever you want to add to the ingredient mix. And then it drops down into in this chamber here, from here down in. Every one of these sections, you can see with the pressure gauges on it, and there's a water line coming in. You control how much water, it's hot water, the temperature of it, and then the pressure of that system. And there's a small hole. Now you got 2 screws, and those screws are moving in opposite directions. So it's like 2 grain augers.
Here are the mixer and auger parts that are out of the machine for cleaning. When the product comes out of the extruder, the shape can be changed with different dies that have different shaped and sized holes on the end.
Yeah, when you get some flour that has a high percentage of carbohydrate or starch, when it's under such intense pressure, high heat, high pressure, and when it hits atmospheric pressure, which is lower, it has a tendency to puff or expand. And so that's why you call it a puff snack.
This machine makes tofu from soybeans.
So we have basically a soybean system. It'll grind. You cook soybean, you soak them overnight in the water, then you cook them in here. It grinds them up into a paste, and then they cook again into this system here. It's just kind of a hot water bath until you pump it up. And then it goes through a screw profile. So inside of here is again your auger, your screw system. It's pushing the liquid
out, leaving the tofu. That's what Mr. David was trying to say when my dad stopped recording.
In the analytical lab, products can be analyzed for a variety of properties. This instrument uses near-infrared to measure moisture, protein, fat, and fiber and starch content. The food samples can be in powders, pellets, grains, paste, cake, meal, and slurries.
The next lab we saw was the pasta lab, which is also pilot scale. They can make dry or fresh pasta in more than 50 shapes. This is the pasta extruder. Ingredients come in at the top and get mixed. It gets pressed out here through extruding dies that give the pasta its shape. All of the NCI's facilities are highly regarded, but their pasta lab is especially well known for its capabilities.
Next up was the baking lab. It's equipped with mixers of all sizes, many types of ovens, slicers, sheeters, molders, a blast freezer, a tortilla press, a fermentation cabinet, and deep fryers. That makes them equipped to make a huge range of products. What do they do after they make them? They test them. This machine measures the texture of food products. This one runs a 3D scan to measure the volume of a product.
And it's not just testing machines. Mr. David says he gets the opportunity to be a taste tester on lots of panels. He said cookie taste testing day was really popular. We missed cookie tasting day, but I came up with a plan. Thanks to the inspiration from the NCI, I decided to make my science project on cookies. You'll hear more about that in a future video, so please subscribe. And we saw so much on our tour, we can't include it all here. If you are a grower of crops researched here, The NCI is creating added value and demand for your crops through innovation and education.
And for the rest of us, we benefit from better selections at the grocery store, tastier foods, and food products that meet growing consumer demands, such as gluten-free, reduced sugar, more nutrients, or greater convenience.
Thank you for the tour, Northern Crops Institute. And stay tuned for my upcoming videos. We have several in the works.